Well, first of all, how many of you guys know Deepgram? All right, good show of hands, and good show of hands from the Deepgram team. For those of you guys who don't know, we have a large presence of Deepgram folks here, so come and talk to us.
You guys have an offsite or something?
Yeah.
That's
so we'll be walking around. We also have an open house.
I'll be there tomorrow, don't worry.
Very nice. But yeah, Deepgram does voice AI. So we started on the speech to text side. We've been doing that for a very long time. More recently, we have expanded to the text to speech side and really the end-to-end voice agent side. So I'm Nick. I am the product manager on the speech to text side of things. I have one product that I really want to highlight today that we've been working on for maybe the last year or so. That's really exciting on the speech to text side. And so let's get started. So one of the things that we've seen across the board in the industry is everything is really moving towards these real-time interactive voice agents. And the existing speech-to-text solutions on the market really fall short for these real-time voice agent AI applications. You end up facing these challenges. One, achieving super low end-to-end latency for a natural conversation. But on the other hand of that same coin is achieving natural and accurate turn taking. So it feels like you're talking to a human, you're not being interrupted while you're still speaking, you're in the middle of a pause. And so you end up doing a bunch of complex things like waiting for silence, doing like custom semantic turn detection logic yourself, and putting all of that inside of your voice AI pipeline and creating a super complex solution that isn't perfect and ends up interrupting people too early, or it waits too long, and people are sitting there for multiple seconds while your agent is responding. So we built a speech recognition model, not just to transcribe, but to converse. And so Flux, we launched a couple weeks ago, about 3 weeks ago now, October 2nd. And it's the first conversational speech recognition model that's out there today. It's designed specifically for voice agent development. So it comes with model integrated turn detection. So turn detection that understands the full context of the entire turn, the full audio and semantic context, far beyond simple VAD and other solutions that are out there today. It's a single API that replaces both your speech to text and your turn detection solutions that you may have used in the past. It is ultra low latency, so you get transcript updates at about every quarter second, and turn detection, end of turn detection, our default P50 latency is like 260 milliseconds, and that comes with the full turn transcript as well. And all of these turn taking dynamics are configurable out of the box. And then finally, and I'll talk a little bit more about the API design later, but we built this in with conversational queue events. So instead of just sending you the transcripts and sending you when the turn ends, we send you these conversational events. Start of turn, for example, you receive a start of turn message that you should then trigger. If your agent is currently speaking, trigger your barge in logic. One of the things we're thinking about is by back channel identification as well there. Eager end of turn, which is a way to essentially say we're moderately confident this is about to be an end of turn. Take the current transcript, start pre-processing your LLM response so you can shave off additional end-to-end latency in your end-to-end system. But really these events tell your agent exactly when it should be listening, when it should be thinking, and when it should be speaking. And now we have a pretty cool little Flux visual here. And with that, I can show you guys the demo. And this is also available at flux.deepgram.com if you guys want to try it out yourselves later. But what you're looking at here is Nova 3 on the right, which is our former state-of-the-art streaming transcription model, and you'll see Flux on the left. So as I start to speak here, you'll see on the right, Nova 3 is continuing to transcribe, and as these partial results finalize, they'll move up into final results up here. But what you'll see on the left with Flux is a little bit different, and I'll try and scroll down so we can keep seeing this. It's maintaining the entire turn transcript as I continue to speak, and on an ongoing basis, it's calculating this probability that it is actually the end of my turn. And when I do finish speaking, it's going to move that full transcript up. See, so it detects end of turn there, and I'm not sure what I have the threshold set at right now, but again, that's configurable. And you can, I think you'll see the eager end of turn here if I have it on. Maybe I don't have it on. So. I'm going to turn this down. But you can see here the end of turn confidence threshold is configurable. This is your eager end of turn setting, also configurable. Let me just show you guys this again.
What is end of turn versus what is eager end of turn?
So eager end of turn, you'll want to use that to basically start pre-processing an agent reply. So it's basically maybe end of turn, like possible end of turn. Really, if you're fully trying to optimize your end-to-end latency, you're going to want to use that because you'll get that response probably 100, 200, 300 milliseconds faster than the actual end of turn. Obviously, that'll vary. But if you're really looking to optimize end-to-end latency, especially if you're working on a pipeline that has, tool calls, RAG calls, or you're using a big LLM for whatever you're building, it becomes really valuable. And yeah, so now you can also see start of turn coming through here and the rest of those conversational queue events as I continue to speak. One example I like to do is phone numbers. So my phone number is 847 487 7277. It's pretty damn good. Shout out to our research team. Not at all.
Does it actually know that it's a phone number, so it has to wait till 10 digits happen and then it's thinking that's the end of turn?
Yeah, so I mean it's been trained on all of this data,
Okay.
And so basically it's looking at the entire context of the turn, and so it does know that I'm halfway through a phone call. But it's not like an entity recognition model that's holding it or anything like that, which you might see in other models.
Can you zoom in a little bit?
Yeah. Is that better?
Yeah.
Okay. So I have slides for this too, but I like the visual here better. So those conversational queue events that I mentioned, Flex, we really designed to be a state machine that kind of takes care of all this, abstracts all of this logic that you normally would have to do yourself via the API design. And so you'll see here, I don't know, can you guys read this okay? It says initial. Yeah, I probably can. I'm not wearing my glasses. But starting in the initial state, I start targeting for my turn. We emit this start of turn event. That's, like I said, trigger your agent barge in if it's currently speaking. Otherwise, I've just started my turn, wait for my eventual end of turn, and then I'm in this turn ongoing state. And if we reach this slightly lower confidence threshold that it is about to be an end of turn, we'll give you this eager end of turn event, pass that downstream to your LLM or whatever downstream system you're using to start pre-processing a response. And at that point, you're awaiting the full confirmation that it was end of turn. If I then continue speaking, we'll send you this turn resumed event, and then you can cancel that in-flight agent response that you've been processing and wait for the next one. And then finally, wait for that end of turn and fire off that response that you've already been preparing.
How do you guys make this all work with different frameworks? So LiveKit, Pipecast, and setting parameters there. So today, I actually did have a chance to play with Flux all day because I talked to my agent, making it better. And one of the things I struggle with is okay, LiveKit has its own bad, it has its own turn-taking approach. So when I keep theirs on, when I turn it off, how do those two settings relate to each other? Deepgram versus what LiveKit has for its turn-taking. I'm not sure, I got that optimized. I just got a YouTube that I found of LiveKit playing with Flux, and they put a repo on GitHub, and I copied those settings, but they didn't feel to me like they were right because you're talking about certain things about turn taking, making decisions, and there you also have a turn taking thing. So
Yeah. So It'll depend on the platform, what exact settings you need to toggle, but typically you turn off the platform level turn detection and then just rely on Flux. That's
How
how
about the
I,
VAD? The VAD still running on the framework in the platform, so
if not for turn detection, if
like Celero is like the one by default used by
in
LiveKit.
LiveKit.
Yeah.
I actually not totally sure. I assume you just turn off the VAD and it relies on Flux's turn detection. That's for sure how it works in VAPI.
We invited LiveKit to the open house tomorrow, right?
Yeah.
Yeah. So we can ask them that.
Yeah. Probably the question for PipeCat, right?
Oh yeah, PipeCat also uses Trello, so yeah, wondering if that should be it's moved away. Also, I have another question. Like you said you can set the threshold, right?
Yep.
Do you have like any recommended value, or
Yeah.
should we just use it?
Yeah. Yeah. So we.
Yep.
It really depends on what you're building. First of all, we have the default end of turn threshold is 0.7. For a lot of cases, I find that 0.8 is a value that people are finding success with. But it depends on like what kind of agent are you building. So are you building something that has a big LLM on the end of it? Are you building something with a bunch of tool calling and like RAG calls in the middle of it? Like, do you care more about not interrupting the user than you care about fast responses, or are you okay with the occasional interrupt? And then that's where eager end of turn comes in as well. So like, if I don't care about the additional like wasted LLM calls that potentially happen from using eager end of turn and doing that speculative generation, I can set that to like 0.4, and maybe I want to be really sure that it's actual end of turn when we do respond. So I'll set end of turn to 0.8 or 0.9 even. And that gives me the opportunity to shave off a bunch of my big LLM latency in the middle, which is where the majority of your end-to-end latency ends up coming from.
Okay. I see.
But yeah, it's very dependent on your use case.
Would it be nice if you have this list of recommended values?
I actually just added that to the docs. Yeah, there's a page in our docs that talks through like here's like an aggressive setup, here's like a deep like middle ground setup, and here's a conservative setup. Cool. What else do I got here? I got some benchmarks. If you guys can see this. Can you guys see that or no?
Come closer. So many seats open. Yeah.
Zoom in one graph at a time?
Actually, why don't we pull up? I feel like I can click this one. Is that better?
Mm-hmm.
There it is.
All right. Well, so this is at least precision. So the one that you guys are probably most familiar with, Celero bat, right here in purple. This is kind of
Oldie but goodie.
oldie but goodie. Yeah, exactly. And then you've got a couple of like bespoke turn detection models here as well. So we got Cat Smart Turn. We've got LiveKit. We've got Chris. And then Assembly AI is like, they call it intelligent endpointing. It's really like variable endpointing, basically. But then you've got Flux up here. And so you can see Flux is very fast and it's very accurate. But yeah, this is the precision latency benchmarks.
Does Flux support multiple languages?
It's only English right now,
Okay.
but that is like probably the by far biggest ask we've
When
done.
Spanish comes
Soon.
When is Russian coming?
They're all coming.
Okay.
They're all coming. But
I
yeah.
did have a question about like accuracy on the quality of the lines. So I'm on the phone,
Mhm.
and I was playing all day this morning by default with Twilio, and then I noticed this, like the transcription is not as good as I thought it should be. And then I realized my production agent's in Telnex, and I use the HD voice over there. And as soon as I swapped it back to that, which had a little bit more latency than the HD voice, but the transcription accuracy was significantly higher. I was wondering if you have any thoughts or tricks on just dealing with bad phone lines and actually improving that, because I think you had like a telephony or something also model, and I don't know if that is better or not, but how do you see handling poor, or compressed audio?
Yeah, so we train our models on all sorts of audio, all of them. We did back in the day we still have Nova 2 phone call, which was trained specifically on that audio. That all got trained into Nova 3. So Nova 3 is pretty good in those scenarios as well. Flux was trained on pretty much, not as much as Nova 3 was, but like all sorts of different audio, and in particular telephone audio. I would say, honestly, like try out the models on your specific audio. This is kind of like the general recommendation we give across the board, because some phone call audio works better on Nova 2 phone call. Some phone call audio works better on Nova 3. We see, depends on the customer, depends on the specific audio, differences and preferences. So the general recommendation is try it for yourself on your specific audio, and then see what works best. But there's also things like noise cancellation and energy filtering, which some customers find success with, and that's also something that we're looking to go to on the research.
Is there any difference between Nova 3 and Flux on that aspect of filtering out noise and trying to...
on noise filtering?
Yeah, noise filtering, or dealing with noisy environments.
No, not specifically. There's not like broken out feature support for filtering out noise on either of them. As of yet. Soon.
Nova 3 is good, so we can get to that level.
Did you find that Nova 3 was better than Flux was?
I didn't do a quick direct compare. I have in production Nova 3, and it's been good. And I don't remember being bad with Twilio in the past either, so I was kind of surprised when I was struggling with Twilio today, and then I swapped it Telnex with HD voice, and bam, I'm like, wow, this is like really good transcriptions. And then I was just missing things left and right, or getting wrong words, which is kind of odd. Maybe it's my settings somewhere. I just didn't feel right, because Nova 3 was doing fine, and then it does great with HD voice, but then somehow Twilio and its crappy settings, and the lowest quality are tripping it up somewhere.
Yeah. Cool. Well, any other questions? Anything else you guys want to see?
Oh wait, so this works on Cloudflare.
Oh yeah.
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 That's why we're
Yeah, and you can get a WebSocket. It will give you the turn protection.
Oh, okay. Got it.
And it's free for all of October.
Oh.